All right, Intro to Algebra students, welcome back to another day of remote learning here. We got two lessons to cover in our fraction unit today. We got lesson 4.3 and 4.4. Okay, so again, like I said in yesterday's video, if you already know how to do this skill, it's a review. Okay, then you might not need to watch this entire video, or maybe you don't need to watch it at all. Okay, use it as a tool for whatever you need. I'm going to show you some tips, like some of the easiest ways that I've found to add and subtract fractions with unlike denominators. I'm going to show you the fastest trick I know to get these problems right nearly every single time if you follow it, okay? But if you're good to go with it, go ahead and start on it. If you want to follow along to see what I'm going to show you today, then go for it. Okay, so let's take a look at a review here, adding and subtracting fractions. So last time in 4.2, we added and subtracted fractions that had like denominators that are the same. Okay, like if we had 1/3 plus 2/3. Okay, we could add those together because those denominators are exactly the same. So then we would add just our numerators and we'd get 3/3. Okay, so today we have unlike denominators that are not the same. So if you check out my example here, this fraction 1/3 has a denominator of 3, and this fraction 2/5 has a denominator of 5. They are unlike, they're not the same. Okay, and here's the big rule. Here's the thing that we got to get stuck in our brains somehow, because this is a very common mistake that people make. You cannot add or subtract fractions unless they have like denominators. Okay, if those denominators are not the same, okay, they got to be the same. If they are not the same, you cannot add these fractions. All right, and this is a very common mistake people make. They look at a problem like this and they simply just start adding it together, but you can't. Okay, you cannot add it until we have like denominators. All right, and this is one of the rules with fractions, and this is why people don't like fractions very much, is because there's all these rules about them. Okay, so what we have to do in order to add this problem is first we need to change both of these fractions so that they do have like denominators. Okay, and there are several ways to go about it. Here's the easiest, fastest, quickest way that I've found to get like denominators, to change these fractions into like denominators, and it works every single time. Okay, and the fastest way to do it is to take and multiply each fraction by each other's denominator. Okay, we're going to multiply both of these fractions by each other's denominator. Okay, so here's how you're going to set it up. Over here, give yourself some workspace, and vertically, we're going to write 1/3, and we're going to leave a little space, and then we're going to write 2/5. Okay, there's your step number one. All right, and now we're going to do this trick here. We're going to multiply by each other's denominators. So here's what I mean. This fraction down here has a denominator of 5. So I'm going to take this fraction 1/3 and I'm going to multiply both the top and the bottom by 5. Okay, this fraction is getting multiplied by this one's denominator. Okay, now let's take this fraction and we're going to multiply it by this one's denominator. Okay, so we're going to multiply both the top, both the bottom, our numerator and denominator, all right, by this 3. So we took each other's denominator and we're multiplying that entire fraction by each other's denominator. Okay, and we're going to do that and we're going to get two new fractions. So if we do this, 1 and 5 is going to get us 5, and 3 and 5 is going to get us 15. All right, and then down here on this fraction, we're going to have 2 and 6, and 5 and 3, or sorry, 2 and 3, and 5 and 3 to get us 6 over top of 15. Okay, so we made two new fractions, and check out what we have. Both of these fractions now have like denominators. Okay, so we've changed them and we want to check to make sure they both have like denominators, and they do. Okay, so now that they do have like denominators, we're going to add them together. So I'm going to take the first fraction I changed, 5 over 15, and I'm going to add the second fraction, 6 over 15. Add them together. Remember, we just add the numerators when we're adding fractions. I know, another rule about fractions. So we're just going to add the numerators to get 11. Denominators stay the same. We don't do anything with them. They just stay 15. Okay, so there is our answer. 11 over top of 15 is the answer we get when we add these two fractions. So this is what this answer is going to come out to be. Okay, so we got to change them using this method right here. That's the quickest way to go about it. Make two brand new fractions, then you're going to add them together to get your answer. All right, so let's take this step and we're going to practice it a few more times. And then I'll have you guys try some on your own and see how you do. Okay. So here's our first, here's our next one that we're going to add, 2/3 plus 1/4. Notice our denominators are different. So I'm simply going to set both of these up vertically. Okay, and I'm going to use my fast little trick here. So 2/3 is going to get multiplied by this denominator. So both the numerator and denominator are getting multiplied by this 4. And then this fraction down here is going to get multiplied by this denominator. So both our numerator, our top, and our denominator, bottom, are going to get multiplied by 3. Okay, so now if we do that, we'll multiply straight across. We're going to get 8 over top of 12. And this one, we're going to get 3 over top of 12. Okay, check it out. We have two brand new fractions. Take a look. They both have like denominators now, so that means we can do the math with them. We can add them together. So let's set them up to add. 8 over top of 12 plus 3 over top of 12, all right, is going to get us 11 over top of 12. All right, and you might have just looked at this and been able to add them mentally. That's fine. If you All right, let's take a look at our next one here. Notice how the next problem we have is subtraction. So let's go ahead and work that out the same exact way. First, we need to get common denominators because this one has a denominator of 15. This one has one of 5. So they're not the same. So we need to change them. So using that trick I've been showing you guys, line these up vertically. All right, so we got 13 over 15. We have 1 over 5. Okay, and then multiply by each other's denominators. So this 13 over 15, I have a denominator of 5 down here. So this fraction is going to get multiplied by 5. And then this fraction down here, since I have a denominator of 15 on this fraction, this is going to get multiplied by 15. All right, both the top and the bottom. Okay, now that we got it set up, let's go ahead and multiply and see what we would come out to with these. So 13 times 5 is going to get us 65. All right, and then 15 times 5 is going to end up being 75. All right, so there's that one changed. This one, we're going to get 15 over top of 75 also. Okay, so take a look. They both have the same denominators, so we can go ahead and do the math with them. All right, and we're subtracting this time. So we're going to go 65 over top of 75 minus 15 over top of 75. Okay, and we're just going to do the math with the numerators. Okay, so if we take that 65 minus 15, that's going to get us 50 over top of 75. All right, and that's going to be our answer. We're going to put that right here, 50 over top of 75. All right, now you might be looking at that fraction and thinking, well, hey, that one could actually be simplified down, and you're right. All right, we can simplify that. We're just not going to do that in this lesson. We're going to do that in the next one. We just want to focus on being able to use this process to come up with our answer. All right, and another thing to add, you might have come up with a completely different answer for this. If you didn't change your denominators this way, you might have gotten something else, which is completely fine. All right, let's take a look at our last one here. We got different denominators. So let's go ahead and change them so that we can add these fractions using the same trick we got, 2/3 over top of 2/9. All right, again, you might have a different method for changing these denominators here. All right, I'm just going with the same one each time because it works every single time, and for some fractions, it's the fastest way to get it done. Okay, so I'm going to stick with this. So if I take a look here, I have a denominator of 9, so this fraction on top is going to get multiplied by 9. And this fraction down here is going to get multiplied by 3 because I have a denominator of 3. Okay, so if I multiply these, let's take a look at what we have. We would get 18 over top of 27. And then we're going to end up with 6 also over top of 27. All right, our denominators are the same. It looks like we're adding. So we're going to take 18 over 27, and we're going to add 6 over 27. And that's going to come out to 24 over top of 27. All right, so that's going to be the answer we're going to put right there, 24 over 27. All right, again, you could actually simplify this down, and we're going to take a look at that process in the next video. All right, but we're going to stick with this answer for right now. All right, so I hope those examples worked out okay for you guys. Go ahead and try these problems out here and see what you come up with. Hit pause, and we'll check your answer in just a few minutes. Okay, let's take a look and see what these would come out to. Okay, our first one, we got 16 over top of 21 was our answer. If you take a look at the math, here's the setup. This fraction got multiplied by 7. This one got multiplied by 3. This is what we ended up with. They got like denominators. Add them together, we had 16 over 21. Okay, let's take a look at our second one here. We had 7/10 minus 3/8. All right, we do the math for those. We're going to end up with, let's see, this one got multiplied by 8. This one got multiplied by 10. We ended up with 56 over top of 80 and 30 over top of 80. But look what I did here. I ended up adding those instead of subtracting them. So let's change some stuff here. All right, so we need to do some subtraction. So let's do that. Okay, so 56 minus 30 is going to get us 26. So that's what we need over here for an answer. All right, my apologies on that. We'll get that fixed right now. All right, 26 over top of 80 would be our final answer for that. All right, and you could have simplified this and gotten something else. That's fine. We're just going to leave our answer like that there. All right. Last one down here, we got 52 over top of 32. Let's take a look at how we got that for an answer. This fraction got multiplied by 4. This one got multiplied by 8. This is what we ended up with here. All right, and then we add them together, and we're going to end up with 52 over top of 32. All right, so check those out. Make sure you guys got the same thing. If you need to make some corrections, go ahead and do that. The last thing we're going to look at here is how we would go about comparing fractions. All right, and what I mean by comparing fractions is if we have this example here, we want to decide which fraction is greater or which one is less, or if they are equal. All right, and the good news is we're going to use the same method we just did. All right, so to compare fractions, we use the same method we just did to add and subtract fractions. All right, same method we did to add and subtract with unlike denominators. Okay, so just like we did before, we took and we changed our denominators so that they were the same. That's exactly what we're going to do here with these. All right, so if you're going to compare these fractions, get yourself common denominators. It makes it a lot easier to compare the fractions. Okay, so let's set these up just like we were doing with the adding and subtracting. Let's take 3/4 and 5/12. We'll line them up vertically. All right, now we're just going to multiply by each other's denominator. So this would get multiplied by 12, and this one down here is going to get multiplied by 4. Exact same steps that we were just doing. All right, so now if we multiply these together, we're going to end up with 36 over top of 48. All right, and then this one, if we run the math on this, we're going to get 20 over top of 48. Okay, notice they have the same denominators, and it makes it easy to compare. All right, 36 out of 48 is greater than 20 out of 48. Okay, so there is our greater fraction. So now we're just going to rewrite this using our greater than symbol. So we're going to say 3/4. And we're going to use this one right here because it's greater. It's saying 3/4 is greater than 5 over top of 12. Okay, and remember the point of our symbol always goes next to the smaller number or the smaller fraction that we got. Okay, so we got 3/4 being greater than 5/12. All right, let's check out a few more and we will see what we come up with. Okay, so if we take a look at this one, we want to decide what symbol would go here if we're comparing 5/7 to 7/8. So we're going to line up our fractions vertically, just like we've been doing. Okay, multiply by each other's denominators. Okay, so this one is going to get multiplied by 7. All right, write our brand new fractions and see what we come up with. We would get 40 over top of 56 for this one. And this one down here, we're going to get 49 over top of 56. All right, now that they have the common denominators, it's easier to see which one is greater. Okay, there is our greater fraction, the 7/8. So we're going to rewrite this. So we're going to say 5/7 is less than 7/8. Okay, we got the point of the symbol with the small side of the symbol pointed toward our smaller fraction here. All right, so that would be the correct one to use. Let's take a look at our last example down here. We got 2/7 compared to 4/14. All right, we'll set this up vertically and get common denominators to compare them. All right, so we're going to multiply by each other's denominator. So multiply both of these by 14 and multiply both of these by 7. Okay, now we'll see what it is that we ended up with. Okay, so 2 times 14 is going to get us 28. And then 7 times 14 is going to get us 98. All right, and down here we'll take a look. 4 times 7 is going to get us 28, and this is still going to get us 98. Okay, so check them out. They are exactly the same. So these two fractions are equal, even though they're different. All right, it kind of goes back to the last video lesson that we took a look at. All right, they are equivalent fractions. So we're going to put an equal sign in between them because they are exactly the same. They're just written differently. Okay, I got a few examples for you guys to try out, see how you do comparing fractions, and then we'll take a look at your answers. Okay, here's the 2 problems that you guys got. So try these, hit pause, and then we will take a look at your answers in a minute. All right, let's take a look at what you guys came up with for these here. Okay, so here's my setup, getting common denominators. This fraction got multiplied by 6. This fraction got multiplied by 9. Ended up with 24 over 54 and 27 over 54. This one was greater, so I have the greater than symbol pointed to this fraction here. All right, and my point, the small end of this symbol, is pointed toward my smaller fraction. Okay, check out our next one. If we change this one to get common denominators, this gets multiplied by 12. This one gets multiplied by 11. We ended up with some pretty large numbers here. We got 84 over top of 132. That one was greater, so my symbol went the other way, showing that this point is going to the smaller fraction here. Okay, so that's what you got for some answers. Hopefully those worked out for you guys. Let me tell you what your assignment is going to be for this 4.3 lesson. So you got these two quizzes to do in Apex. All right, when you get those done, you can play the video for 4.4. We'll talk about simplifying fractions. And then I got these two assignments for you guys to do in Apex for 4.4. All right, see how that goes for you guys. Thanks for watching.